everyone, Morgan here. So we are on page 9 of the Unit 1 Honors Chemistry outline. And we're talking about graphing today. And this is going to be a review of stuff that you have learned about in your algebra classes. We just kind of want to point it out to you. So here's a graph that I have. And this graph is a mostly good graph. There's some problems I left in it that I want to point out to you. But in general, it's done well. So what I've got here is a typical straight line function. Okay, I have got a y-axis, I've got an x-axis, and I've even let the computer generate the equation for that line. Okay, title. All graphs need to contain a title. It should pretty much be center top. Okay, that's up here. It's a nice bold face. It's very clear. Typically, what we do with the title, okay, is we describe what we are measuring. Our graphs are going to come from data that we have collected in a laboratory situation. Now, I'm going to label the axes, and you'll see that that's done for both of these here. And first off, it's going to have the name of what we are measuring, mass in this case, volume in this case. And it will also have the units for what we are measuring, grams and milliliters. So name and units. Okay? Up here, I have the equation in the y equals mx plus b format. And hopefully you're remembering that you can calculate the slope by doing y2 minus y1 over x2 minus x1. Okay, rise over run. Okay, now on these graphs, the x-axis is going to be referred to as the independent variable, and the y-axis as the dependent variable. The value of y depends upon what the value of x is. Okay? So we are pretty much controlling the x values and seeing what y values come out from that. Okay? Now, slope, and this isn't discussed that much in your algebra class, but slope always has meaning. Now, in this case, it's mass over volume. So m equals mass over volume, which means the slope of this line actually represents density. In physics, we often will do distance over time, and the slope of the line would be velocity. Okay? Now, you'll notice with this graph that it is computer generated. And there's something that I could have done better with this graph. There is a whole lot of open space there and even right there. I should have probably adjusted these axes down so that my minimum volume was probably 10 milliliters and not have this wasted blank space. And my maximum volume would be 100 based upon this scale. Okay, I'd also do the same thing up here to get rid of this empty space and that empty space. I want this line to be as big as I possibly can. Okay, now trend line. Trend line tells you what the data is doing, what its trend is. It's not plain connect the dots. Very seldom will you ever get experimental data that looks, really that nice and clean and perfectly on a straight line. So a trend line will go through all the points with some above and some below as your best possible fit. And then this equation that the program generated for me is the best fit equation. It doesn't mean it's perfect because this is experimental data, and experimental data is not perfect, okay? But the graphing programs understand that. And in calculating it, it puts it in the y equals mx plus b format, and it's giving me the slope for the line right there. Okay. All right. So we're going to do a lot of graphing this year. I'll give you some good practice on it also. All right, keep your eyes open for another video that I do, which actually takes you through how to generate one of these graphs step by step. Okay, thank you for tuning in. This is Morgan signing off.